Okay, YouTube, this is my first in a series of videos in which we're going to be working with basically rational expression operations, so adding, subtracting, multiplying, and dividing with fractions. So the first thing we're going to hit here in this video is basically what we mean by the simplest form of some rational expression. Or what we mean by a rational expression is basically a ratio. So what you're going to see is we're going to have multiple different expressions involving algebraic, numerators and denominators, and a ratio with one another. We're going to want to simplify those and know what do we mean by, well, the simplest form has been achieved. So when we talk about a fraction, we say that the simplest form basically implies that the top and the bottom of the fraction share no common factors that we could, reduce them by, okay? The only common factor they should share is either going to be positive 1 or negative 1. So it would be valid to say in this expression here, we say a, b, and c are non-zero real numbers or variable expressions, then the following property applies. And basically what it's saying is, well, the top and the bottom here share a common factor of c, so we can just cancel that out. We can cross those out and we get a over b here. So in each of these expressions down here, I'm going to talk about how it is that we typically simplify rational expressions. Step number one is always going to be this: factor the numerator and the denominator. So this is basically all we're ever going to do. Factor the numerator and the denominator. And we're going to look for common factors in the top and the bottom. So one thing I want to dissuade you of, is here we say, well, everybody has an x, and technically everybody here does have an x, and we could cancel them out. But we want to write the top instead of as x squared plus 5x. We'd really rather write it as something times something else, because this is, we're going to find in certain instances here, if we had something like this, a lot of people make the mistake of canceling out across the sum or a difference. It could have been differences here, but you can't do that. The only time you can cross cancel a factor or cancel a factor out, is really what I mean to say, is if the top and the bottom are multiplying by the same factor, which is a factor in this product. So looking at this right here, we're basically going to factor the top and the bottom, and what we're looking for are things like GCF. We're looking for trinomials, okay, trinomials. We say differences of squares, so differences of two squares. Okay, and sometimes, just sometimes, we have grouping. But these are the factoring methods we tend to pick on, and always the GCF first. So when I look at the numerator here, I say, well, notice they have a common factor of x. So we'll factor out the x, and we get left with x plus 5. And on the bottom here we say, well, x, well, this is technically x times x. We could write it as x squared, and technically it is x squared, so I want to leave it that way. But x times x is what it technically is. So I notice that this x here is going to cancel out with one of these x's down here, and what we get left with is a simplified expression where we have x plus 5 over x. And I notice that the top and the bottom now, the top is technically all of this. So x plus 5 and x are not in common, so they do not reduce with one another. Okay, so this would be our simplest form of this rational expression. Over here, I notice that the bottom is a difference of two squares, and I notice that the top is a trinomial where our a value is 1. So starting with the top, we'd say, well, if it's factorable, then these two numbers have to multiply out to be a negative 12, but they have to add up to be a negative 4. So I could think of some pairs here. We say like negative 4, positive 3, but that adds up to negative 1. Even if I switch the signs, it's positive 1. So how about 6 and 2? And I would say, well, which combination would give me a negative 4 when I add them up? It'd have to be a negative 6. We say minus 6 plus 2 is our top here, and then on the bottom, since it's a difference of squares, we'd say, well, then I would square x to get x squared, I would square 2 to get 4, and these are conjugate pairs. So we would say that these two here, factors on the top and the bottom, would cancel out, and what we're left with is just this simplest form expression, x minus 6 over x minus 2. And this is just be what it is, because I notice that I can't factor these any further, and these are not common factors, okay? So don't get the impression that you can cancel these out. You can't. These would have to match identically. So in the next video, we'll talk about how you multiply fractions. Cheers.